Hi all. In this video we'll make an amortization table for a loan. To begin, I've opened up a worksheet titled Amortization Table. To make an amortization table, I need to know some information about the loan. In this example, I'm using a loan amount of $100,000 at an interest rate of 5% compounded monthly for a 15-year loan. You can see this information is already on the spreadsheet with PV equal to 100,000 representing the loan amount, the R value of 0.05 representing the interest rate, the N value of 12 corresponding to the monthly compounding and monthly payments, and T equal 15 corresponding to the 15-year loan. This information allows me to use the appropriate formula to find the payment, PMT, and I'm going to put that into B6. I'll enter the formula now, and you may want to look this up as I go along, but it's going to be equal the present value of the loan, $100,000, times R divided by N, and you'll notice I'm using the references here, divided by the quantity 1 minus the quantity 1 plus R B2 divided by N B3 raised to the open parentheses negative B3 times B4, N times T, close parentheses again, and that should give me the payment of $790.79. Now I'll want this rounded to the nearest cents, so in C6 I'm going to have this rounded up to 2 decimal places. So round up this quantity, comma 2, that should round that up to 2 decimal places. Alright, for my amortization table I'm going to need several columns, one for the number of payments, one for current balance, one for payments toward interest, one for payments toward principal, and the ending balance, and I've typed that information in. In this example, the amount of time is 12. There's 12 payments per year for 15 years, or 180 total payments. So I'll put that under the number of payments. So we should see there's 180 total payments. Okay. The current balance to begin with is the initial balance, so that should be B1, and I'll make a reference to B1 there. The payment toward the interest is always going to be the current balance times R B2 divided by N, in this case B3. So we're going to see that first payment toward interest should be $416.67. I again want to round that. This time I'm going to use the round function, round. Again, I'm going to round that to 2 decimal places, so I need comma 2 here, and then enter. So again, it's round the number I'm rounding, comma 2, then close parentheses, and now that's rounded to 2 decimal places. The payment toward the principal is the remains of the payment after I pay the interest. So again, that's going to be the payment of $790.80 minus $416.67. As a formula, this is going to be C6 minus C9. So we're going to see for that first payment, $374.13 of the payment goes toward paying off the balance. To find our ending balance, we're going to take the current balance, that $100,000, minus the payment toward principal. Whew. Now the hard work's done. Now the power in using Excel is really in automating this process rather than in doing the calculations. So what's really nice here is the new current balance is just that ending balance from the previous line. So I'm going to put a reference here to I'm going to type that in, E9. Just bringing that down. And I'm going to try to turn off my phone. That probably should have been done before I started this. Alright, the payment toward interest, well, I'm just going to do the same thing I did before. I'm going to take the current balance times B2 divided by B3. So let's just cut and paste this down here. I don't think it's going to be $79,000. Alright, so again, I wanted that payment toward the interest to be the current balance, and the first line in C9, that was the value in B9 times B2 divided by B3. In C10, in the new line, the new row here, that should have been B10 times B2 divided by B3, but if you look in the formula bar, you're seeing it's B3 divided by B4. What's happening here is I used a relative reference when I wanted an absolute reference. So let's go back here, let's put some dollar signs with the B2 and B3 because those should stay constant. Now cut and paste those, and 415.11 looks like a much better value. And in fact, that's correct. If I look at the formula here, it has B10, the current balance, times B2 divided by B3. And that's why I wanted it, again, rounded to 2 decimal places. The payment toward the principal, I can copy and paste this. That doesn't look right. What's going on here is C6 should have been an absolute reference. Let's make that the case. Copying and pasting this down now, we see the payment toward the principal looks right. The ending balance formula actually should continue to work. Alright, so again here, the power in Excel is automating this process. All of these cells here should represent the correct formulas I want all of the way down the rest of the amortization table. So if I copy and paste this down, I have an amortization table that shows me all of the 180 payments and how they actually work out. And I can see that this 180 payment had a little bit too much, $1.72 extra. They wouldn't make me pay that, but the whole amortization table is now here. One really nice thing about the way we set that up is I can change the original loan amount, and everything adjusts to take that into account. I can change the interest rate, I can change anything about this in the way that I've set this up, except for the number of payments. If I change the total number of payments, I'll have to alter that column. So back to the original. Another nice thing about having the whole amortization table in front of me, I can look at some scenarios. So let's suppose after the first year, I come into some money and I make an extra $10,000 payment. Well, I can look down and see what that does to the overall loan. Looks like I pay this off on the 156th payment, so I save 2 years in the loan by doing that. Alright, last thing I want to show you here is that there's also in Excel some financial formulas here. If I'm in the Formula tab, I can go over to the financial formulas. There's all sorts of different ones, but in particular I can look at the payment formula. And if I follow these instructions here, if I look at what the rate means for these examples, it says the rate is, well, the rate means here the percent divided by the number of times per year that it's used. So in this case, it's B2 divided by B3. N per is the total number of payments. Here that's B3 times B4. And the present value is $100,000, which is in B1. Hitting OK here, I see an amount of $790.79, which looks a lot like what we saw before. I also see that this is red. The particular way that Excel does this formula, this comes up as a negative number. To make it positive, I can just insert a negative between the equals in the payment formula, and I get that $790.79 that I expect. It is a penny off of what we rounded to, but that's probably okay. Alright, that's all for today. Have fun excelling.